Hello students, we are learning lesson number 4, effects of electric current. And before this we have studied uh, when electric current is passing to that particular resistor, and that resistor is producing heat, and for that we have studied Joule's law of heating. Joule's law of heating. So in that H is equal to I square RT, we have obtained that equation. Now after this we are going to learn next concept, and that one is the heating effect of electric current. Next concept is the heating effect of electric current. Heating effect of electric current. Electric current. So what is heating effect of electric current? If you pass current through a conductor, if you are passing current through any conductor or wire, so due to the resistance of that particular wire or conductor, that particular conductor, it is producing heat, and that heat is emitted, that heat is exchanged with the environment, and that conductor is producing heat, and sometimes that light is also produced and that light is emitted. So what is heating effect of electric current? Magnetic effect is there, heating is there, and the chemical effect. Before this also we have studied, but here also we are going to learn. So heating effect of electric current: when electric current is passed through any conductor or through a conductor, electric current is passed, that conductor get heated. It is called as a heating effect of electric current. So in that different things we have studied. Suppose example you will take electric iron is there, electric oven is there, electric cooker is there, electric heater is there, electric bulb is there. In these devices, when a conductor is there or resistor is there, and that conductor or that particular wire is having some resistance. Suppose in that, if you will consider electric heater or electric cooker, in that one coil is there, and that coil is having high resistance, and when an electric current is passed through that particular coil, then heat is produced. So these are the devices which are working on the heating effect of electric current. After that, next thing is that suppose in case of electric heater and electric cooker, in that one of the conductor is used and which is having high resistance, conductor of high resistance is used. That coil is made up of conductive material, and that conductive material is there nichrome wire. In case of the electric heater, in case of the electric cooker, nichrome wire is used, and a nichrome is the alloy of nickel and chromium. So that nichrome wire is used, and that nichrome wire is producing, it is having large or high resistance, and because of that high resistance it is producing heat, it is producing light as well, and we are using it is as a coil. So another thing is there, suppose you will consider electric bulb. In case of electric bulb, one filament is there, so solenoid coil type filament is there, and that coil or that particular small filament, that filament is made up of tungsten wire, and that tungsten wire is having high resistance, and because of that it is producing more amount of heat, and it is emitting light. What is the melting point of that particular tungsten wire? 3400 degrees Celsius. 3400 degrees Celsius. So heating effect of electric current is useful concept or is useful phenomenon, and we are using it in our daily devices. So electric iron is there, electric cooker is there, electric heater is there, electric oven is there, electric toaster is there. In all these devices we are using heating effect of electric current. So points we will take. First thing is the first point, when an electric current is passed through a conductor, it gets heated and produces heat and light. Is called heating effect of electric current. Heating effect of electric current. So second thing is there, electric cooker, electric heater, electric iron, electric bulb. These devices are working according to heating effect of electric current. So third point is there, in case of electric heater and electric cooker, one coil you are using, and in a electric heater and a cooker, a coil of nichrome wire is used, which is having high resistance, so it is producing large amount of heat. So nichrome, it is the alloy, nichrome wire is the alloy of nickel and chromium metals. So because of this alloy, it is having high resistance. It is not a pure metal. Because of alloy we have studied, it is homogeneous mixture of two or more metals. Fourth point is there, in electric bulb, the solenoid coil of tungsten wire is used. Solenoid coil of tungsten wire is used as a filament. It gets heated and emits light. And the important thing is there, melting point of tungsten wire is 3400 degrees Celsius. How much is there? 3400 degrees Celsius. And at this much temperature it is melting. So electric bulb is working continuously up to this temperature, and if temperature will increase beyond this limit, then that filament breaks, so it will not work. Another thing is that in case of the electric devices, examples we can tell which are working, and these are examples: electric cooker, electric heater, electric iron, electric bulb. These are working according to the principle of heating effect of electric current. So After this, next concept we are going to learn, and suppose if you draw a diagram of the electric bulb. So how is the diagram? That diagram also I am going to draw. In case of electric bulb, diagram is already given in the textbook. So how is a particular electric bulb constructed? That one I will show. So suppose one glass cage is there, in that two wires you are taking, and here glass support is there, here glass support is there, and here one solenoid type coil is there, solenoid type of coil is there. And sometimes we have like this. In the textbook, that screw type it is shown here. Screws are shown like this way. That electric bulb is like this. So here will be glass bulb is there. This one is there. Tungsten filament is there, tungsten filament. This one is there. Glass support is there, glass support is there. Next thing is there metallic wire is there here, metallic wire to conduct electricity. And this one is the metal cap, you can say, and here these are the points, they will conduct electricity. And in this, two things are there, either a vacuum is there, vacuum, or nitrogen and argon gases are there. In this nitrogen, and argon gases are there. So electric bulb is like this, and in this one coiling is there, small coiling, and that one is there, tungsten filament is there. And if you electric current will pass, this coil get heated and it is emitting heat and light. Glass coating is there, glass bulb is there, and the glass support is there. And in the glass cage bulb, or you can say glass cage also, you can say cage. So in this, gases are taken, nitrogen and argon gases, because these are what is argon gases or argon gas. In this, if you take vacuum also, it is fine. So it is not allowing chemical reaction, or in case of that filament will not get burnt. If it will come in contact with oxygen, then it will break. So that inert atmosphere is maintained inside the bulb or a glass cage. So next thing is there we are going to learn, and that one is there, magnetic effect of electric current. Magnetic effect of electric current. Before that magnetic effect, two more points we have to study, and that 2 points are there. First one is there short circuit, and our second one is there, first one is there short circuit. Short circuit, we are knowing home circuit, or in case of the connection at the home, it is having 3 wires. In case of home connections, electric circuit, home electric circuit, in that 3 wires are there. Which 3 wires are there? First one is their live wire, second one is their neutral wire, and third one is their earth wire. Live wire, neutral wire, and earth wire. So, and current is passing through the live and neutral. So, earth wire is used for the protection to pass the high electric current to the ground. So, another thing is there, due to the overheating, if that claddings or covering around that particular that wires, cladding around that particular live wire and neutral wire is removed, coating removed, then a live wire and neutral wire, these are coming in contact with each other, and when that live wire and a neutral wire coming in contact with each other, at that time large amount of electric current is passing through that particular circuit, and a spark is produced where that particular live wire and neutral wire, they are coming in contact with each other. Spark is produced, and if any combustible material like paper, clothes, cotton, plastic, wooden articles, if such combustible materials are there nearby that particular short circuit, and then it causes fire. So what is meant by short circuit? When a live wire and a neutral wire, these are coming in contact with each other, live wire and neutral wire, they are coming in contact with each other due to some reasons. Suppose coating around that particular live and neutral wire is removed, for that different reasons will be there, by due to the friction also it will may be removed. So when these are coming in contact, then a huge amount of electric current is passing, and it is producing spark, and it is producing fire. So short circuit, electric home connection has 3 wires, which live wire, neutral wire, and earth wire. Second point, when live wire and a neutral wire and a neutral wire comes in contact with each other due to a removal of coating around them, then large amount of current flows through circuit and causes spark. And if any combustible material is present in contact with this short circuit, then it catches fire. And the next thing is there, to avoid short circuit, we should use electric fuse in series with home circuit. So if a large current is passing through that particular circuit, then this fuse, electric fuse wire will melt. Electric fuse wire, also you can say electric fuse wire will melt, and then it will stop the electric current. So like this way, this question was asked this year, March 2020. That question was asked on the short circuit. So if any combustible material is present in contact with this short circuit, then it catches the fire. So how short circuit occurs? When live wire and neutral wire, they are coming in contact with each other, and at that time spark is produced, and then short circuit is occurring. Next thing is there. Next concept is the overloading. So in case of the overloading, so during the summer season, we are using many electric devices. Different devices, and these different devices, they need large amount of electric current, and that electric current is drawn from the transformer, and we are getting electricity from the transformer which is nearby our house, and from that transformer we are bringing that particular electric current. So during the summer season, refrigerator is working, then television is working, electric fan is working, then ACs are working, electric cooker is working, and so many electric devices, electric heater is also working. So many electric devices are working at a time. So suppose you will consider summer evening, and at that time so much hot is happening. At that time different devices are working. So all these devices, if they are working together, so they need more amount of electricity, and that more amount of electric current is drawn from the coil of the transformer. And if more amount of electric current is drawn from the coil of the transformer, that coil of the transformer melts and the circuit breaks. So this one you are saying it is overloading. So in case of the overloading, what happens, that one we have seen. So overloading in summer evenings, many electric devices are working at a time, such that electric bulb electric cooker, refrigerator, or you can say AC, then refrigerator is working, fridge is working, again electric fan is working, electric fan. So all these devices are working together, and because of that large amount of electric current is drawn. So due to this large amount of electric current is drawn from the coil of transformer. Due to this coil of transformer breaks and supply gets stopped. This is called overloading. It is called as overloading. So I think you understood what I mean by overloading. So to avoid that particular overloading and short circuit, we have to use electric fuse wire. To avoid overloading and short circuit